one of the things that drew me to your online profile and your TED talk and stuff was I read one of your pieces in Wired magazine about teleporting, and I thought maybe we could talk a little bit about that. So, and then maybe we could talk about like cryogenics and time travel and shit in a second. So let's start with teleporting. Is it possible to teleport? Do you ever foresee a time when it might be possible?
I think the answer is yes, but it depends, unfortunately, on what you mean by teleport. So if by teleport you mean your atoms, the things that are actually making you up, disappears and reappears somewhere else instantaneously, that's just not possible. Right. And the reason is that we know there's a speed at which information travels through the universe. Like things can't move faster than the speed of light. There's no way to get information from here to Alpha Centauri faster than the speed of light. Unless you want to do like wormholes and warp drives, and we could put that on hold for a second. But actually teleporting, like, disappearing and reappearing somewhere else instantaneously, definitely not possible. Unless you're willing to go at the speed of light. If you're willing to go at the speed of light, then potentially that could actually be done.
So are we sort of, is it the common consensus then in the scientific community that you couldn't go faster than the speed of light? And like where you mentioned about warp drives a minute ago, because I was a bit of a geek coming up. Me and my brother used to watch Star Trek together, and the idea that you could go like, warp 3 or warp 5 and warp 9, and is that just a bit far-fetched, or?
No, it depends a little bit on what you mean. So like there's a loophole there that we can exploit. The universe says you can't move faster than the speed of light, like nothing can ever. And that's fine. But sometimes you have to think about the question you're asking, like, do you really want to move through all the space between here and the next star? Is that really your goal? Or do you just want to get there? Because if you just want to get there, then you can get there faster than light can get there by going through space, because space itself is flexible. Space itself can bend and twist. And so if, for example, you could compress the space between here and there, then you don't need to break the speed limit in order to get there faster than light otherwise would have.
But then,
so if you want to get to like a star that's 10 light years away, light would take 10 years to get there. But if you could compress the space between here and there so it's effectively a few centimeters, then boom, you can get there in a few microseconds.
how would you compress space?
Yeah, how would you compress space? Great follow-up question from an engineer. You're like, okay, let's get to work. Step one.
how do we do this? Yeah.
Well, the thing to understand is that space is not like an abstract backdrop to the universe. It's not just like the stage on which things happen. Most people, when you think about empty space, they think about, vast blackness, or they think about like a coordinate system, like X, Y, and Z out there. And that, when you pull particles out of everything, that you have just nothingness. But that's not what space is. Einstein tells us that space is a thing. It's dynamical. That means that it can change. And space can, for example, bend. What is gravity? It turns out gravity is actually not a force. It's the bending of space when you put a mass in it. So the Earth goes around the sun, not because there's some like Newtonian tug of gravity pulling on the Earth, but because the sun bends space in such a way that it's more natural for the Earth to move in a circle. The way, for example, those pennies, sometimes in museums you see these like funnels you can put a penny in and it'll spin around for a long time before it finally drops in. That penny is moving on a curved surface, and so its path is not to just move straight but to move in a curve. The same way the Earth moves around the sun. So space is a thing which can bend and twist and ripple and expand. It can do all sorts of things in response to mass, which means you can do things like compress it or expand it.
That is like, when I was saying at the beginning of the podcast about like how, a layman like me would just kind of struggle to get his head, like, it's just blowing my mind. I'm like, the way, so as you're describing it very eloquently, I like the way it's landing in my head, because I tend to think visually, is that where you say, okay, space is not this sort of big backdrop, it's more, it is a thing, or it could be a thing. I imagine then, so is it like a sort of invisible fabric that we can't see, or?
It absolutely is. It's like a fabric. It's dynamical. It's sort of like we are fish scientists. We've been swimming through this thing thinking that it's nothing, and then discover, oh, it actually is a thing, and it has properties. It can
Right.
change. It can move. It can bend. It can be connected in weird ways.